All right. Topic 03, fundamentals to lab exercises. So we're gonna do the lab exercise. You're required to write some code to multiply two 3-element vectors. So when you see vectors, what do you think is a data type that can be used to represent vectors?
Integers.
Yeah, okay, this is you can use integer. All right, no worries. But in this case, if you look at the data, what do you think? Should you use integer or what?
Float.
Should you use float? Okay, that's the data type. Okay, what about, see, a vector is basically what? A list of numbers, right? So when you think of a list, you must think of a one-dimensional array. A list of items is basically a one-dimensional array. Now, it says here, element producing a single value. So when you do vector multiplication, so this one is nothing to do with programming, it's mathematics. So when you have two vectors and you multiply them, you get a single scalar value. X and Y are two 3-element vectors. T is the transpose of the vector, Y is the scalar output. Okay. Now there's a code here, it's available on Blackboard, but it's also available on Moodle. You can download vector.c. So this is the very basic code that we have. I'm going to increase the font size for you. Okay. Right. Now, what is this Y transpose? Actually, you don't have to worry about the transpose, because you see this is one dimension, right? See, what does transposition actually means? Row become column. So if it's a 3 by 2 matrix, transpose become 2 by 3. But if it's one dimension, there's nothing to transpose. If you before transpose and after transpose, it's the same. There's no difference to it. So this is a 1D array. Okay? So you can ignore the Y transpose over there. All right? So declare. Let's look at the guidance given in vector.c. Declare the variables for your vector. I want you to have your lecture slide. You actually can find how all the steps, the answers to every step can be found in your lecture slide. So make sure you have your lecture slide open. So you go to topic 03. All right, we're going to go to modules 2 and 3. So there are about 27 pages here. If you press Ctrl F, you can do a search. It's very useful to do a search of a PDF. So let's call this array. Okay, you want to search for the word array. All right, there's 19 references to array. So simple arrays, right? Array example. All right. Okay. Now, what do you see here? Does this look familiar? If you don't know, then it's okay. All right. So now, how do you declare x? So what is the first vector? What is the first variable called? It's called x, right? So what is the data type you want to use? Float. So float x. What is the size according to the question? 3, right? So 3 2 elements. So x3. So x3. Okay. Now you can actually this is the easy way to do it. You just assign it straight away. I'm not going to use the values inside here because they are long-winded. I'm going to use some simple values. 1, 2, 3. All right. Now next one, float y. Okay, y, and I'm going to show this. I'm going to do this the longer way. This is the longer way. The longer way, you have to assign the values manually. So what is the starting value for y0? So y0, I am going to assign to number 4, and y1 I'm going to assign to number 5, and y2 I'm going to assign to 6. right? Why am I using these numbers instead of the numbers with decimal point? It's because it's easier to verify whether my program is working by using a simpler number. If you store a float, if you store an integer into a float, the 1 will become 1.0, that's all. It doesn't really make any difference. So there are two words. Now I've got to ask you a question. You see the result here? Why don't we do this? Everyone pay attention. Why can't I do this? Is it wrong to do this? Should I change the result to an array? Is it necessary? Why is it not necessary? What kind of multiplication are we doing here? Vector multiplication, right? Vector multiplication will result in single scalar value. So the output does not have to be a array. So use array only when necessary. Okay, if you only need one value, using an array is overkill. All right. Now, what about the vector multiplication? Let me explain in case you've forgotten. All right. Let's look at a value. So this is x, y. What is the location? Array start from, what is the start? What is the address of the first element? 0. So x0 multiply y0 plus x1 multiply y1 plus x2 multiply y2. Okay, so basically that is the vector calculation. So what is the variable that contains the result? It's called result. Okay, result. The expression is assigned to result. So we'll start with x0 multiply y0 plus x1 multiply y1 plus x2 multiply y2. Is there, now let's look at the printf. Is there any necessary, have they completed the printf? The result of the multiplying the vectors is %f result. So they actually have done the last part for you. So if you look at this simple program, you notice a pattern. What is the pattern here? Underlying pattern for all programming problems. Input, process, output. So in this case, this is just a simple calculation. So input, process, output. Okay, there must be some sort of output, right? So let's compile and run. Okay, if you get a fail to execute, access is denied. This is because all the lab computers now actually have a new antivirus. Okay, it's called Panda Endpoint Protection. So what you need to do is very simple. This is how you bypass this error thing. Make sure you save it to desktop. Right now, I'm running it from downloads. You need to save it to desktop. If you save it to desktop, the Panda error will go away. Okay, so it's 32. So how do you get 32? Very simple. 1 times 4, 4. 5 times 2, 10. 4 plus 10 is 14. 6 times 3 is 18. 18 plus 14 is 32. All right, so that's how you get the value. All right. Now, some students might be wondering, so how come you have this method over here, and then how come suddenly you change the method over here? This is to show you that there are two ways to do it. In future, you can use the top method. The top method is the easier method. Okay? So you can choose. There's two ways to do it. So don't get confused. Why is he using two methods? It's just to show you that there are two methods available. Okay? Anyone having problem with this question? Anyone cannot compile or some error or whatever? If you have, you can put up your hand. Anyone? No? So can we move on to the next question? All right, excellent. So the next one is extend the exercise to multiply two matrices. You have A and B size 3 by 3. Together produce a matrix. So The output matrix is called the C matrix. So the first step, can you tell me what is the first step to do? What's the first step you should do? You should delete all the old stuff, okay? It's not really relevant. Okay? That was a trick question. All right, now tell me what's the first thing I need to do? What's the data type for X? What's the data type for A? Float. So float A. Now what is the dimension for the array? 2 dimension by 3 by 3, yeah? 3. Okay. 2 dimension by 3 by 3. Now set the value. So you can actually you can just cut and paste it. All right. So if you go here, you select row by row. So you take row A. You cannot select the whole thing because you'll go to B also. So you copy row A, and then you can paste it directly into the. And make sure when you separate it, each number is separated by a semicolon, not semicolon, by a comma. All right. Select, copy, paste. All right. All right. Next, the last row. Okay. All right. So we have this is called a variable declaration for A. Now we'll do B. Okay, we'll do B. So how does B look like? All right, same, huh? So same steps. Copy the first row. Paste the first row. Make sure there's a comma separating every value. Okay, done. Make sure double check the values are correct. 7.3, 5.2. Okay, 7.3, 4.9, 30.7, 2.4, 4.9, 10.2, 7.3, 5.2, 1.7. Okay. 2.2, 6.2, 2.4, 0.9. Okay, excellent. Now, what is the next part? What do I do next? Guys, tell me what to do next. Declare result, right? In this question, the result matrix is C, right? So what dimension should be? What are the size? What is the size of C? So float C 3. Is there any data in C right now? There's no data, right? Okay. So tell me what is the next step. Now we've done the input. The data has already been inputted. Now we do the process calculation. All right. This one is back to we do some mathematics. Okay. Row times column. Okay. Listen up. Listen up to the concept first. If you understand the concept, you can do it very easily. So the first step is you take the row A, multiply against the first column. That is the value for C00. Okay, C00, take first row, multiply first column. What comes after C00? C01. For C01, take the first row, multiply against the second column. What's the next value in C? C02. Take the first row, and multiply against the third column. So now this is how it look like. Okay, just listen. I don't need type, just listen first. So A00 multiply B00 plus A01 multiply B10. Okay, plus A02 multiply B20. Okay, so that's what I just did. I multiply the first row of A, multiply the first column of B. So now let's see how it looks like if you want to write the equation. So if you've forgotten how to do this, this is high school mathematics. Go to Google, type this website. It's a very fun website. It's called Math is Fun. Okay, just type Math is Fun, and don't forget to look for, it's under matrix multiplication, but it's a square matrix multiplication. If you look under matrix they won't give square matrix. They will show different. So if you want to recap, you can go and check it out. So now A00 multiply B0 B0 0 plus A0 1 multiply B1 0 plus A0 A02 multiply B2 0. Okay? So basically the first row multiply the first column. So this is the address of the first column. B00, B10, and B20. Okay? Now, actually you see there's actually a pattern. You can just copy over this thing. So you copy over. Okay, I'll show you. You must address, but don't just simply copy and paste. When you copy and paste, you need to know what values to change. So now, what is the next element in C? C0, 1. A row is still fixed. What changes is the column. Okay, so the next element is the middle column of B. The first element in middle column B is 0, 1. And the middle, this is the fifth element in B, is 1, 1. And this is the 6, 7, 8. This is the eighth element, is 2, 1. Okay, so this is the middle column of B. 0, 1, 1, 1, and 2, 1. So this is the middle column. So copy this again. The pattern repeats itself. Okay, what is the next element in C? C0, 2. So once again, the A row still fixed, but the column have to change. So we go to the last column of B. Last column of B, the first element is 0, 0, 1, no, 0, 2. Okay, 0, 2, 1, 1, 2, and finally 2, 2. Okay? So this is row 0, column 2, row 1, column 2, row 2, column 2. All right? So we have done, so what have we completed? We completed the inputs for the first row of the C matrix, the output matrix. Okay, let's continue. Let's continue with the next one. The next one is the, now that we have finished, so we have finished this. We finished this, multiply this. Okay, I'll highlight here, this, multiply this, done. So now that we have finished the first row of A, we should move on to the second row of A. For the second row of A, the same concept. Multiply against the first column, then multiply against the second column, and multiply against the third column. Okay? So actually, you can cut and paste this. If you're really aware, you can actually follow. It's very simple. Don't simply cut and paste, but you don't know what to change. Just observe what I'm changing. So when you paste this, now the C, we move on to the next column, the next row. So the row becomes row 1. Row 1, column 0, row 1, column 1, and row 1, column 2. Okay? Now, A has to change. Okay? A has to change. A becomes row 1, column 0, row 1, column 1, and row 1, column 2. So the A changes. So make sure A uniformly changes. So you make sure wherever you make changes for A, just change A. And if you change A, that's all you need to do. Yay, done. There's no need, because the B column address keeps on repeating itself. You notice that? The B column doesn't change. All we have to do now, earlier for the first row of C, we used the first row of A. Now, for the second row of C, we use the second row of A. Does that make sense, guys? You guys understand what's happening? All right, good, good. If you don't understand at any point, you can stop me and ask me what's happening. Okay, let's copy this again. All right. Okay, now we go down to the bottom row. So row 2, column 0, row 2, column 1, and the last element is row 2, column 2. So C we already fixed. Now we know A has already been changed. Okay. A has already been, no, A needs to change. Okay, that's not A. Now we need to change. Now we go to the bottom row of A. Okay, this is 2 0, 2 0, 2 0, 2 1, and finally 2 2. Okay, that's the bottom row. Remember, bottom row of A, row 2, column 0, row 2, column 1, and row 2, column 2. So 2 0, 2 1, and 2 2. 2 0, 2 0, 2 1, and finally 2 2. So I changed the row of A, but the column pattern keep repeating itself in the same manner. Okay, can, right? Actually, there's another way of doing this whereby you actually use loops. Okay, loops is only one single formula. However, loops you have to use 3 loops. You have to use 3 loops because you have for every time you do multiplication, you have to do addition. So you need actually 3 loops. There are 2 dimensions, so row and column. So there's 1 loop for each dimension and another loop for the addition operation. Okay. Now, programming follows a pattern. What's the pattern? Input, process. No, that's not. It's not input, output. Input, process, output. So have we done the input? Where is the input? This is the input, right? These are all the values, right? This is the process or the calculation, right? What is the next step? Printf or the output. So printf, okay. Now what is the data type for all this? C. Float, right? So what's the symbol? %F. So we'll put 3 of it in one row. Just make it look like a matrix. Okay. And maybe we want to do some controlling for the size of what it available. So we'll set space. How many spaces? We set 4 spaces on the screen, and out of these 4, 2 will belong to decimal point. So 4.2 F. 4.2 F. Okay, comma. What's the first row? C 0 0, comma C 0 1, C 0 2. Okay. So now you can actually just copy this. You don't have to like type it again. Okay, copy this. Okay, paste and paste, and of course put a new line here /n so that it won't stick in one line. You want it to appear like a matrix, right? Whereby three elements in one row. Okay. Okay. Then of course you have to change this. Row 1, column 0, row 1, column 1, and row 1, column 2. And this one is row 2, column 0, row 2, column 1, row 2, column 2. Okay, let's compile and run. Let's see what happens. All right. Now, okay. Now how to double check. There's a few ways to double check. Maybe I made some mistake. So one way to double check is you use a calculator, but it's troublesome. But I got a solution for you. You can cheat. This is how you cheat, but you have to cheat smartly. So you use an online matrix calculator. But not all online matrix calculator is good. I'll show you the good one. So online matrix calculator, the problem with the online matrix calculator, you have to paste one by one. I found one where you don't need to paste one by one. You go to, where is it? How come not here? Yeah, Bluebit is the second option. So you go to Bluebit. So go to Bluebit. Okay, when you go to Bluebit, you go to matrix multiplication. All right, there's 2 boxes here, and you can't. It's not perfect. You can't paste the entire thing at one go, but you can paste row by row, which is much faster than pasting one element at a time. So you see, So you got matrix A. So you just paste in the first row. Okay. Then you go to the second row. Okay. And you paste it. Then just okay. Next. Next one is wait. Okay. Next row. Okay. So I like this. In other online matrix calculator, you have to paste one value at a time, which is such a trouble. Okay, this one you can paste row at a row, one row by row, which is actually much faster. Okay, all right, almost done. Okay, and then multiply AB. Now let's double check whether I got it right or not. Okay, the first row is okay. Okay, 948, all right, 8149. Okay, 23. All right, it's correct. Of course, you cannot, this is the weakness of the calculator. You cannot control for a number of decimal points. Okay, this is the limitation. Okay. All right. So please do this. This is very important. You might not understand this. Every time you do some calculation in this lab, so make sure you take out a calculator, punch it. Make sure whatever you do in your program mirrors real world. It's no use if you got some value, you think you're very happy, but your value is nonsense. Okay? Make sure it works in real world. Okay? Okay. Okay. We'll go back to this. Okay. Anyone having problem with this? Do you want this code? Do you need this code? You want me to share this code with you? Yes. All right. Okay. The first code was so easy I didn't share, so I'll just okay. Wait, I will use wait, hold on, okay. Font size. Wait, just give me a second, Okay. All right. Snaggy is a very good tool. If you have never used it, I like to use it in my teaching. So basically, I'm going to share a screenshot with you. So the screenshot will be uploaded to this URL. So you just go online to this URL and you can actually view this. But the weakness of, not a weakness, but it's only available for a few hours. So you go to this website, right click and download the image. The image is a screenshot of the solution. During the semester, I'll be doing this a lot. Okay? So just go to this website. Because I noticed that those sitting behind cannot see my screen, right? So I'm sharing my screen literally. Can somebody test that the link works? Because sometimes it's very hard to type the link. Can work, right? And then, okay, remember, so when you see an image come out on the screen, right? You right click and download the image. Can you do that? You cannot depend on this link. You can only depend on the fact that if you got the link, capture the image, save the image. This is your solution. Snaggy. No, follow the spelling. Sorry, I took it down. This is the Snaggy. Okay? It's not Snaggy. I know a lot of people have problems. So every semester we have problems. But people have difficulty. LPJ, F capital, 9 L capital. LPJ, F capital, 9 L capital, dot JPG. It's not 1. It's L. I just said it loudly, L. Yeah. L, it's not 1, huh? 1 has a little podium down there. In case, guys, please, this is how 1 looks like. Let me see how 1 looks like. I know some people are typing 1. This is how 1. This is 1. Okay? And this is L. There is a very big difference. Okay? Okay, not very big difference, but it's not that. Okay. All right. Let's go on to the next one. So you have the solution. All right, so if you're having problems, you can look at the thing and then match up, see where you made a mistake. Okay. Any problems with this question? Anyone need me to explain anything? Can? Quite straightforward, right? It's just matrix. You learned this in high school, correct? How to do matrix multiplication. But of course, when we learn loops, the code will be much simpler. You realize the code is very long, right? There's 9 equations. It's not practical. You know why? What if you had a 10 by 10 matrix? You have to write so many equations, right? If you use loop, it becomes so much easier. All right. So in the future, after we learn loops, we will show you loops. So now there's one more exercise. Exercise number 2. We have to modify to do addition, matrix addition. Matrix addition is very simple. It's much more simpler than addition. So we will recycle this question, recycle this solution. So I'm going to create a new source. And I'm going to paste it here. All right, the first thing is I'm going to delete everything related to multiplication because we are no more doing multiplication. All right? Do I need to delete the printf? Guys, need to delete the printf? No. Because the printf is not affected, right? It's just showing the output. So addition is very simple. So let's take the first one. What is the first element of C? C, 0, 0. So to get the first element of Z, you take A, 0, 0 plus B, 0, 0. That's all. Okay, plus B, 0, 0. So it's a direct addition with no extra operation. You see, for multiplication, there's an extra addition operation. But in this case, for addition, there's just addition. There's no extra. Okay, so you can actually copy and paste this, right? So C00, the next element is C01, A01, B01. Okay, paste C02, right? C02, A02, B02. Now, let's do for the next row. Copy the all three. Okay, yeah. Okay, now we go to the next row. So now is row 1, column 0, row 1, column 1, and row 1, column 2. Okay, change. Exactly, just change it directly. Okay, 1, 1, 1. Okay, that's all. Direct, it's a direct translation. Okay, copy this. Okay, after we finish row 1, what is the next row after row 1? Row 2, right? So row 2, 2, 0, 2, 1, 2, 2. 2, 0, 2, 1, 2, 2. 2, 0, 2, 1, 2, 2. Okay, done. Fairly easy. Okay, the printf stays the same. Does everyone understand this 4.2f? Anyone want me to explain this? Quite straightforward, right? 4 actually stands for the total number of space allocated on the screen. Out of this 4-digit space allocated on the screen, they said that please allocate 2 digits after decimal point. So that's why 4.2f. So compile run. It'll ask you to save. Make sure you save on desktop, or not you will get a panda warning error. It's a very cute name for antivirus. So we'll add. Okay, let's double check. Okay, you can do it manually or you can use the calculator. Okay, so what you do is don't close this window. Okay, so don't close this window. Online matrix calculator. Go back to bluebit.gr. Now in this case, look for addition, matrix addition. Now go back to the earlier matrix because we're just recycling it, right? So you can just copy and paste. So from the earlier calculator, you copy and paste here. Make sure you arrange it nicely because this is delimited by spaces. Okay. Matrix B. Okay, A plus B. All right, let's see whether my output is correct. Now this is the earlier one. Compile run. Okay, 10.7, 9.3, 4.9, 2.9, 0.8 negative, negative 8, 13.5, 2.8, 2.6. So whatever work you do in the lab, make sure you validate that you are getting the right output. Don't be happy when you see a number. Okay? Because the number may not be correct. So you need to validate it. Okay. You don't need the solution for this, right? Do you need it? Okay, especially for those sitting behind. Okay. All right. I'll share a screenshot for you. It's a very cool tool. I like it. I use it all the time. I used to use another tool which is actually will give you the text. Okay. Then what happened was students just cut and paste that they don't want to type. So then I decided, why don't share text, share a picture. So when you share a picture, what happens is they are forced to type. Because that's the only way anyone can learn. You have to type the example, okay? So go to Snaggy again, Control V, and then copy the URL. Okay, so this is the next one. So same one. Okay, for those sitting behind, this is my gift to you. All right, so you don't have to stand up. In fact, I'll do this all the time because people sitting behind have difficulty seeing the screen, right? So I think from now on, if I stop, I'll just share the screen on this one. The U is capital, if I'm not mistaken, okay? And if I'm not mistaken, the Y is capital, okay? This is this. Can somebody test the link? Does it work? Do you guys need the solution for the first question? Yes. No, first question is so easy. Okay, I'll give you the solution. Pay attention. It's good. This is the solution. The solution actually from the lecture slide. All right, so you have it. Okay, the lecture solution is in your hands. Okay, it's actually from the lecture slide. It's from slide number 1. How come they don't have slide numbers? Okay, slide there is a slide 49. Okay, if you want the solution for question number 1, go to the lecture slide for module 2 and 3. It's slide 49. Okay? Slide 49 is exactly the way I saw it. Not exactly, but similar. Okay? Right. All right, any questions? No. Okay, we can leave early, I guess. Okay, has everyone signed the attendance? Who's having the attendance paper? Who is having the attendance paper? Did you give it back to me? No, I don't have it with me. You guys are group 5, right? 6. Now, where is the attendance for group 6? Who's having it? See? I know I don't have it. I have 6 cents. I haven't received it yet. Okay, that's all, folks. Thank you. See you next week. So the pattern is like this. The first week you have lab assessment. Next week I give feedback. I'll mark it, and you'll see your paper. You'll know how much marks. You do corrections. After that, the week after, what happens the week after next? Tuition free week, correct? Tuition free week, right? So after tuition free week, you will have a lab test. All right. So be prepared. Okay. Thank you so much. See you guys. Bye bye.
Sir, just now the paper you gave us, was it a quiz or a lab test?
Lab test. Quiz is online quiz. The word quiz is used for online. It's available on Blackboard. Okay? I use the word lab test. I don't want to use the same word. Some people might call it quiz, but I call it lab test. Okay? Okay, thank you. Bye-bye.